Kinetic energy and gravitational potential energy are two concepts and two formulas you're going to get very familiar with. They're incredibly common exams questions. Right, so let's consider each in turn. Let's look at kinetic energy first of all. Anything that is moving has kinetic energy. The word kinetic, it comes from the Greek kineo, which means to move. So you don't need to know that for the exam. Right, so if we've got an American footballer, what makes them have more energy? Well, the faster they're moving, obviously the more energy they've got. So speed, and of course the more massive they are, the more matter they have, the more mass, the more kinetic energy they have. And that is apparent in the formula. Kinetic energy is a half times the mass times the speed times the speed. Okay, so if you notice speed appears twice, it's actually speed squared. Sometimes you use the word velocity squared. Speed and velocity are similar. There is a difference which we'll see later on. So the formula for kinetic energy is big E little k for kinetic, a half mv, and then if you notice a little squared comes up, and it's that squared that has an interesting effect later on. Let's look at an example. Before we do that though, let's have a look at the triangle. So in this triangle you've got kinetic energy, capital E little k for kinetic energy. That's the international symbol for kinetic energy, and that's a half times the mass times the speed squared, or velocity squared. So here we go. Here's an example. We're going to look at a car, and this car is moving, and because it's moving it has kinetic energy. If it wasn't moving, the velocity would be zero and have no kinetic energy, because a half mv squared when velocity is zero is nothing. Its mass is 800 kilograms. The speed is 5 meters per second. You stick it in the formula. Kinetic energy, EK equals a half mv squared. I hope you memorized that. EK equals a half mv squared. Stick the values into the formula. You get half times 800 times 5, and of course you multiply by 5 again because it's velocity squared or speed squared. That gives you the answer of 10,000 joules, which could be written down as 10,000 J, capital J, or 10 kilojoules. The K means 1,000 joules, so 10,000 joules. A funny thing happens if you double the speed of something. Most students would think that the kinetic energy would therefore double as well, but it doesn't. It actually does something else. It quadruples. And the reason why is because of that v squared. We're going to do a quick calculation now to prove it. You see the speed has gone from 5 meters per second to 10 meters per second. You stick the values into the formula. EK equals a half mv squared. A half times 800 times 10 times 10 gives you the answer this time, 40,000 joules, or 40 kilojoules. And it's the v squared that is responsible for that. Anything you do to the velocity, okay, you must square as part of the formula. So it's summing up there, if you double the velocity of the kinetic energy, it increases by a factor of 4. You have to square what you do to the velocity. So we've got some examples here. If when the velocity was 1, the kinetic energy was 1. If the velocity was 2, it would be 2 squared, so it becomes 4. If it was 3, it becomes 3 squared, 9, 4 squared, 16, 5 squared, 25. The v squared has the effect of quadrupling, so the squaring has the effect of increasing the energy by squaring it as such, any increase. Right, the next type of energy we need to look at is stored energy, and specifically gravitational potential energy. And we need to consider something going a long way up. This is Donald Trump. He's getting to the top of the building. He thinks he's Superman, but of course he isn't. He isn't that special. He's gained a lot of energy by going to the top of the building. He's got gravitational potential energy. And then when he jumps up and thinks he can fly, well, of course he can't. And all that gravitational potential energy changes into kinetic energy, and he makes a bit of a mess on the floor. So the gravitational potential energy depends on some factors. Well, obviously the more massive Trump was, the more energy he would have. The higher he went up, the more energy he would have had. And the final factor, which many students don't realize, is the strength of gravity. If gravity was weak, it would have less energy than if gravity is strong. So the gravitational field strength has a factor. We're going to look at this a little bit more closely. We measure this in newtons per kilogram. And it's basically a measure of how strong gravity is. The symbol for that is newtons, or n/kg. You will be given the value on the Earth as being 10. It's actually 9.81, but 10 is what we're given in GCSE. And it basically means that for every kilogram an object has, there will be a force of 10 newtons. So you can put that in a formula, which is gravitational field strength. Gravitational potential energy is mass times gravitational field strength times height. The formula should say there. So it's EP equals mg times h. EP equals m times g times h. Again, in a triangle, it would look like this, with EP at the top showing its potential energy, gravitational potential energy, not elastic potential energy, not kinetic energy, and it's mass times gravity times height. You need to be able to rearrange that formula. Sometimes you may be given the potential energy and they say, well, work out the mass, work out the gravity, work out the height. So rearrange those formulas to make M or G or H the subject. And again, because they're triangles, what you do is, if you want to find out what M is, cover the M with your thumb, and you're left with EP equals G over H. G is EP over MH, mass times height, and H will be, well, I'll leave it to you. If you don't understand how to do these triangles, there is a video, or there will be a video, showing you how to use these triangles. Right, let's now consider the person jumping off the top of the tall building. You may be given problems such as skiers going down slopes or roller coasters perhaps. And what we have here is you should know that the potential energy you have at the top of the building would equal the kinetic energy at the bottom. All that gravitational potential energy is changed to kinetic energy. The exam questions like to say that you can ignore any of the minor energy changes. So for example, as you go through the air, you push air out of the way, so that gains kinetic energy. It'll be very, very small. And so you'll be asked to do some calculations, okay? So if we have a half mv squared, which is the formula for kinetic energy, that will equal the mass times gravity times height. Now if you notice, you've got mass on both sides of the equal signs, which means you can cancel them out. So now you've got a half v squared equals gh. Multiply both sides by 2, so you get v squared equals 2gh. And then if you square root both sides, you're left with v equals the square root of 2gh. What's the significance of this? Well, it is showing you that mass does not play a part on how fast the object falls down. It's down to the height and the gravitational field strength. V is square root of TGH, and that's it.